Messier 2, Globular Star Cluster. Messier 2, M2, also known as NGC 7089, is a globular star cluster located in the constellation Aquarius. It is situated approximately 37,500 light-years away from Earth towards the center of our Milky Way galaxy. M2 was discovered by Jean-Dominique Maraldi in 1746, but it was Charles Messier who included it in his catalog in 1760 as the second entry, hence the designation M2. Messier 2 has an apparent visual magnitude of about 6.5, making it visible with binoculars under good conditions, though it appears as a faint smudge to the naked eye. It has an apparent diameter of about 16 arc-minutes, but its true physical diameter is around 175 light-years. Cluster contains hundreds of thousands of stars, with estimates suggesting around 150,000 to 1 million stars. Globular clusters like M2 are some of the oldest objects in the universe. M2 is estimated to be around 13 billion years old. Messier 2 is known for its high density of stars in the core, where stars are packed closely together. This cluster includes various types of stars, from red giants to blue stragglers, which are thought to be the result of stellar collisions or mergers within the dense environment. M2 has been studied extensively for insights into stellar evolution, particularly because of its variable stars like R-Lyrae variables, which are used as standard candles for measuring galactic distances. Observations have included detailed studies with the Hubble Space Telescope, which has helped in understanding the dynamics of the stars within such densely packed regions. For those interested in observing M2, use a telescope with at least a 4-inch aperture for a better view. Larger apertures will reveal more detail. It's best seen in late summer or early autumn from the northern hemisphere. In the southern hemisphere, it's visible during winter months. Messier 2 is not only a beautiful object to observe, but also a treasure trove for astronomers studying stellar populations, dynamics within globular clusters, and the history of our galaxy. It should be added that astronomers have not yet come to a consensus regarding the distance to the M2 cluster. Along with the estimate of 37.5 thousand light-years, another value is no less persistently mentioned on the network, 55,000 light-years. This disagreement looks very similar to a banal error in converting miles to kilometers, although this could not happen in astronomy. In fact, the difference in the distance estimate is due to the use of different methods. The method of direct parallax measurement gives a smaller result, but at such a distance, parallax measurements are extremely unreliable. The method associated with the Cepheids and R-Lyrids gives a larger distance to the cluster, although it cannot take into account the absorption of star light by the interstellar medium, and as a consequence, a drop in their brightness with distance, which near the plane of our galaxy no longer obeys the inverse square relationship. Does the truth lie somewhere in the middle, at the level of 46,000 light-years? In this case, it is hardly correct to assume such a solution as the most probable. In addition, the shape of the M2 cluster is noticeably flattened, which indicates a fairly rapid axial rotation. This gives rise to the assumption that the globular star cluster Messier 2 in its distant past is the core of a dwarf galaxy that merged with other similar galaxies, forming our Milky Way galaxy in the first few billion years of the universe's existence. There is also a new clarification regarding the age of the cluster. It is most likely somewhat younger, not 13 but about 12.5 billion years. But according to the results of some studies, the age of the M2 cluster is estimated to be less than 12 billion years.